Hi guys, I just wanted to do a few short examples, some electronic configurations that you guys have been working on. And don't forget about your quiz tomorrow at 11:30 a.m. So here is our periodic table, and I just want to do some isoelectronic examples. So again, isoelectronic, when we hear that word, okay, that means atoms and ions with the same number of electrons and electron configuration, meaning their electrons are all located in the same orbitals for their entire electron address. So looking at our periodic table, I'm going to choose to do, let's see, we're going to do some ions. So we can say the configuration for calcium with a +2 charge, right? It's a metal. It tends to lose 2 electrons to form a positively charged cation with a +2 charge. This is isoelectronic with the potassium ion, okay? And they're also isoelectronic with argon, a neutral noble gas. And they're also isoelectronic with chloride, okay? And also with sulfide. And then I'm going to say etc. So we're going to look at a couple of examples. So again, if you look at the periodic table, argon has 18 electrons. So here's argon way over here. And all of these have 18 electrons, and they're all in the exact same configuration. So what does that configuration look like? So let's take a peek at calcium with a +2 charge. So here's neutral calcium. +2 means calcium lost 2 electrons. So if we count back 1, 2, so 1, 2, we're essentially writing the configuration for argon. Okay, so what might that look like? Okay, so we have to start up here in level 1, or energy shell 1. Here is level 2. Here is level 3. Here is level 4, etc. Those are our main energy shells away from the nucleus where electrons live. So essentially period number is your energy shell. And then remember, if we've been checking out our Special Khan Academy videos that have been helping us with these sections, this is called our S block. So anytime you're touching one of those boxes, you're touching an S-shaped orbital. Okay, we can remove those over there since that's just a repeat. These 6 groups over here, this is called our P block. Okay. And then our intersection here, this is our D block in there, and then we have our F block down here. Now the only thing with our D's, starting right here and so on for each of these subsequent boxes here, is that the energy shell is N-1 to get the number. So this is 3D, 4D, 5D, and so on right there. All right, so for our calcium ion, and if you're looking at your periodic table, I would start on my far left corner here at level 1. Okay, and then I just keep following on the periodic table. So we have 1s, and we can fit 2 electrons in there. And then that's all there is in that first row. So we jump down to the second row, and we have a 2s orbital, and there's 2 electrons that can fit in it. So here we are. Here's the 2s and 1, 2 electrons. We're still not to our argon position for our 18 electrons. And then now we're over here, which is our 2p shell. So if you count how many boxes there are 6 to represent 6 electrons that are in those orbitals. There's nothing left in that row, so jumping down, we are now at 3s, and there's 2 electrons there. Just counting our boxes. 3s2, so 1, 2, and then moving over to the right, we're right here, and this is 3p. We're almost to our 18 electrons. 1, 2, 3, 4, 5, 6. So we have 3p6. Now this is a total of our 18 electrons if you count up those numbers. 2 plus 2 is 4, plus 6 is 10, 11, 12, plus another 6, a total of 18 electrons. Now this would be the same configuration for all of these up here. Okay, that's the same configuration for all of them. Okay. Now, let's look at another little example. Okay, let's check out a funny. Let's look at copper. Okay, now copper has a total of 29 electrons. Okay, but they're not quite how they appear on the periodic table. So let's look at another example. Copper. Copper is one of those special ones. Okay, so looking at copper, we got to start from the beginning. 1s2, 2s2, 2p6. We're following the periodic table left to right, moving down our rows. 3s2, 3p6. Now, again, that gives us 18 electrons so far. We're still not to copper. Now we're right here. So 4s2, we'll write that down, and then the minute I touch this blocks, it's not 4 anymore. This is level 3, and it's a d orbital right here. So 4s, then 3d. Now this is what a lot of people think for copper. They think it's 4s2 because they're counting their boxes, and then they go 3d9. Well, that's not actually the case for copper, and that's not the case for silver right below copper. Okay. So it is not how it appears. It's actually 4s1. It moves one of its electrons so it can completely fill up all of those d orbitals. Okay. So here are our 29 electrons of copper. Okay. Now, something interesting about this transition metal, and all transition metals, when they form ions, okay, so this we know means it lost one electron, but the question is from where? You can't just count back in the periodic table, so I can't just go, oop, it's right there for 28 electrons. That's not true. It's true that it does have 28 electrons, but it's not isoelectronic with nickel. So something important to point out is that transition metals lose their s electrons first. Okay. Now, which s electrons are we looking at? Well, that needs to come from our outermost region. Okay, so level 4, that's outermost. Okay, and then this is completely filled here. We don't want to upset that balance here. So this is where we're going to remove our 1 electron for the copper 1 ion. Okay, so when we write this one, we're going to write 1s2, 2s2, 2p6, all of that's the same, just like neutral copper, 3s2, 3p6, okay. This 1 electron goes away because copper 1 lost 1 electron, and now we simply have 3d10. So there are our 28 electrons for the copper 1 ion, okay, but it is not like the configuration for nickel on that periodic table. Now, for elements that have really large quantities of electrons, you could see how this process could get really, really slow. So you were taught the noble configuration. So, for example, if I wanted to write the shorthand notation for copper right here, I can easily do that. Okay? So instead of writing all of this right here, which this is the configuration for the noble gas argon, okay, I can write for copper, again, shorthand, which is called the noble gas configuration, I'm going to write argon and then everything else that comes after it, which is the 4s1 3d10, where argon is representing the first 18 electrons, and then you've got the other 11 right here for a total of 29 for copper. So again, this is our noble gas configuration. Okay, so again, it is just a shorthand for, writing configurations that could get substantially long. We could do the same thing here for our copper 1 ion. This represents argon, and it's 18 electrons, but since we're talking about copper 1, we don't want to forget our 10 other electrons right here. Okay, so that would be the shorthand notation for the copper 1 ion. All right, guys, so hopefully you've been doing great in this section. We've had pretty good feedback, people liking those Khan Academy videos. They are so awesome. I really enjoy them too. So just keep sending me your questions, and good luck tomorrow. Talk to you guys soon. Bye-bye.